a quick look at our schedule. I just gave back test 3. I didn't have time to update my spreadsheet, so to give you like a progress report of where your grades stand, so it's not filled out yet. I will bring that to class on Monday, sort of a where you stand right now. We have got 4 more lessons, including today, a review for the final, and the final. Only thing between now and the final is Project 5, which will really, really, like, wink, wink, help you for the final exam, right? So do the project, right? Yeah, so Project 5 is due a week from today, the 15th. You know everything you need to know to be able to complete this project right now, so just do that whenever. If you don't have a copy of Project 5, I might have some more, and it's definitely posted in Moodle also. Okay. All right, so today we're going to talk about solving exponential equations and log equations. All right, so I'm going to look at each of these. I'm going to solve each of these in my head without doing any specific technique, right? What do you raise 5 to make 25? 2. So in this case, if I wanted to solve this equation, I would say x equals 2. All right, what do you raise 3 to make 1 over 81? 4. -4, yeah. You got to remember the rules of negative exponents. 3 to the -4 is 1 over 3 to the +4, which is 1 over 81. And then what do you raise 1/2 to make 16? If it was 4, it would be 1/2 times 1/2 times 1/2 times 1/2, which would be 1/16. If you want to flip it, make the exponent negative. All right, so we can do it in our heads sometimes if the numbers are special, right? An exponential equation is an equation that has a variable in the exponent. So these 3 that we just solved were all exponential equations. So we're going to take a look at how to solve these using a logarithm as opposed to just figuring it out in your head. So step 1 is to isolate the exponential expression. So my equation is 2 times 5 to the x equals 50. I want to isolate the exponential 5 to the x. So how could I get rid of that 2? Divide by 2. So I just have 5 to the x equals 25. Okay. Step 2 is to take the natural logarithm of both sides of the equation. You can actually take any base logarithm you want. I like natural log and common log because I have calculator buttons for those. And once I've narrowed it down to those 2, I typically choose natural log because I only have to write 2 letters. Which saves me half a second. So I'm going to take the natural log of 5 to the x and the natural log of 25. Take the natural log of both sides. And then step 3 is I'm going to use that property of logarithms that we talked about right before the test. It says when you have an exponent, when you take the log of something to a power, you can take that exponent and drop it down in front. So this is going to turn into x times the ln of 5 equals the ln of 25. And then how would I get x by itself? Divide by ln 5, because this says x times the ln of 5. So if I divide both sides by ln of 5, that would get the x by itself. So the ln 5s cancel over here, and I get x equals ln 25 over ln 5. And then I'll put that in my calculator because I have an ln button. And let's see what I got here. Ln 25 divided by the ln of 5, and I get 2. And then you should go back and check. Go back and look at your original equation, 2 times 5 to the x equals 50. If I put a 2 in for x, 2 times 5 squared, does that equal 50? Yes. Check. So that's how you use a logarithm to solve an exponential equation. The key is the step that I drew in green here. The reason you take the log of both sides is because it can bring that exponent down from the exponent and turn it into multiplication. Okay, now we're also going to be able to solve equations that have logs in them today. And the goal for solving a log equation is to convert it into an equivalent, but easier to solve, exponential equation. You might have to do some manipulation with log rules before you can do the conversion. So step one, isolate the log expression. So I want to isolate the logarithm all by itself. How could I do that? Divide by 2. So I have that the log of 5x equals 2. And then I'm going to convert this to an equivalent exponential equation. Now, since there's no base written there, what do you assume it is? 10. So I've got an imaginary little 10 right there. So what equivalent exponential equation could I write? Yeah? Yes. 10 squared equals 5x. 10 is the base in both the logarithmic and the exponential equation. And then the 5x and the 2 swap places. But 10 squared is actually just 100, right? So this says 100 equals 5x. Divide both sides by 5. And x is 20. We should go back and check our solutions. Check that 2 times the log 5 times x, so putting in a 20 for x, we want to make sure that equals 4. So this says 2 times the log of 100. Log of 100 is 2. So this is 2 times 2, which does equal 4. All right, that makes sense? So the key to solving a log equation is 1, isolate the logarithm, 2, rewrite as an exponential equation. Do I have more? Yeah, okay. Okay, so in those two examples, we didn't have to use any log properties to isolate the logarithm. But often we have to use the log properties of logs to isolate the logarithms into a single log. Okay, so I rewrote them here for your reference. You're welcome. All right, so here's a slightly more complicated one. And what makes this a little more complicated is that the logarithm appears twice. We get 2 logs in this equation. So the first thing I want to do is collect all the logarithms on one side of the equation. So I would add log base 2 of x to both sides here. So I get 2 equals log base 2 of 4x plus log base 2 of x. Now, if you think back to our properties of logarithms day, that's an expanded form. I want to squish those 2 logarithms into a single logarithm. And how do I do that? Multiplication, yes. So I can write this as a single logarithm where I multiply the 2 inputs. So 4x times x is 4x squared. Yeah. That's this property right here, right? You have the sum of 2 logarithms. You can combine them into a single logarithm by multiplying the 2 inputs together. And then, same thing as before. Rewrite as an exponential equation. So my base is 2. My exponent is 2. And that equals 4x squared. And then I solve for x. I rewrote this as an exponential equation. Base 2, exponent 2 equals 4x squared.
Okay. Yep.
Yeah, I should make one of my 2's look different so you know where they came from. Yeah. One's curly, one's regular. So you can tell where they came from. All right, so 2 squared is 4. 4 equals 4x squared, which means x squared equals 1, which means x is 4 plus or minus 1. And we should check. Always check, especially with log equations, you'll see. So I'm going to go back to my original equation. 2 minus log base 2 of 1. Does that equal log base 2 of 4 times 1? So what's log base 2 of 1? To phrase it another way, what power do you raise 2 to make a 1? 0. So this says 2 minus 0. Does that equal log base 2 of 4 is 2. So yeah, they're the same. But now I also have to check for negative 1. I'm just going to put it up here. 2 minus log base 2 of putting in negative 1 for x. Does that equal log base 2 of negative 4? Log base 2 of negative 1. If I was going to say that another way, what power do I put on a 2 so that the answer is negative 1? 2 to what power makes negative 1? Doesn't. Yeah, there's a reason you're all silent and can't think of anything, right? There is no power you can raise 2 to make a negative 1, right? Because remember, think about the exponential function and what it looks like. If I was going to graph 2 to the x, it looks like that. No matter what x I put in, I can't make a negative, right? I can't make a negative. So the log function has as its domain only positive numbers. I cannot take the log of a negative number, so this is just nonsense, right? I can't plug negatives into the log function, so I go back over to my equation, and I'm going to say x equals 1 is actually my only solution. Negative 1 is extraneous, and that is why you check. Dividing both sides by 4, yep. Okay, your turn.